Our task was to create an earthquake-resistant structure and a shake table to simulate an earthquake. The earthquake we made was a replica of a 7.0 magnitude earthquake that hit Zimbabwe, Africa 8 years ago. The reason we chose Zimbabwe was because many people didn't think Zimbabwe had many earthquakes until the 7.0 earthquake hit. No deaths or injuries were recorded. The way we created our structure was with Legos for the bridge. We used Jello jigglers for the ground. The Jello jigglers was the shake table that proved to work well while keeping the Lego bridge in place.
The reason we used Legos was because Legos can't crack or crumble similar to steel. The arc in our bridge is to keep it from buckling. Buckling is when something breaks due to the different seismic waves. Seismic waves are waves of energy that travel through the earth when two faults rub against each other. Faults are breaks in plates deep in the earth.
To go more into depth about our shake table, which is a structure to simulate an earthquake, we made it out of Jello jigglers to represent the ground. We shook the structure in a side-to-side motion to create S-waves. S-waves are secondary seismic waves that move slower than primary waves and therefore reach the surface second. Then we shook the structure again, but this time in a back-and-forth motion to create P-waves. P-waves are primary waves that move the fastest and reach the surface first.
When we shook the table, the Jello made perfect S and P waves and kept the bridge in place. The bridge also stayed in place because the Legos were built too wide and had an arc.
In conclusion, we built a sturdy bridge out of Legos, created an earthquake with P and S waves, and our structure still stood.